Don't ask her about her age. She's probably 25 already, pretending to be one of us. Ready? Oh, did you just record that? Uh-oh.
Yeah.
Zoom to the birthday girl. Happy birthday to you. Happy birthday to you. Happy birthday to Crystal. Happy birthday to you. All right. So, now, normal distribution. This is the last part that we need to do, but it's going to be broken into two sessions, today and Monday. The first thing we want to look at is, what is a normal distribution? How can you identify that the graph of a density function that you are looking at or presented with is a graph of the normal distribution, the graph of the density function of a random variable which is normally distributed. So the note that I've just given you is quite explanatory, so we're just going to run through it. Let x be a continuous random variable with density function whose graph looks like this. Two major things. If you want to really justify that this is a normal distribution, it is symmetrical. You know what it means to be symmetrical? Good. And it is bell-shaped, that's why I put a bell here. Okay? There's no, for every bell you might have seen, it's always symmetrical about that center. Is that not? So if it is bell-shaped and it is symmetrical, then it is normal distribution. What is at the center or whatever will be discussed as we go on. So I said we call this a normal distribution. Maybe not too small, right? We can see, right? Okay? Now, in what cases do we have a normal distribution? Can I ask everyone to please come around here? If you have a normal distribution, the implication is that later you will see that the mean is always at the center of the normal distribution. The mean is always at the center. The implication is that most of the data are very close to the mean. Only a very few are either more or less than the mean. Do you understand that? So let's look at a situation whereby I give the class a test. Okay? If I give the class a test, the average, class average, will be the center. You might have one or two people who by any chance gets higher than the average, like very high. I might have someone who's not feeling too well, who got a very low point, or for whatever other reasons. Do you understand? There are numerous examples. If you look at your textbook also, there are numerous examples you can find there. Look at fruits. You go to Samuel, you got oranges. There's an average weight. What you expect that orange to weigh, or even the size, for you to really call it the kind of orange you want to buy, right? Maybe, oh, the diameter should look like this, but you might just have some orange that is just so small, and it's so cute to you, then you buy that too. But it's rare, you don't see that all the time. Or you just see some orange that is so huge, which is out of the ordinary, like, oh my God, is that an orange? Okay, I need one of that, because you don't normally see it. But most of them, they cluster around the average mean. When you have a distribution like that, you are dealing with a normal distribution. Okay? One example, I hope these are not the examples I want to test. Walking distance from home to school. There's an average time that you expect, provided all the students live in maybe Nova City or something like that. There's an average time you expect everybody to spend walking to school. But you might have some people who either don't like to walk so fast, or who just take their time like someone does when she's eating, but they know who. Or you might have someone who walks so fast. I think this guy walks so fast. Are you sure? The last time you and I were working together, I think I was running after you.
Really?
Yeah, I think so. You might not know, but I was dying. Do you understand? So you might have that. So you see, people that walk so slow, Marissa, for example, she might be here. So Brandy might be here. Why the rest of us? We normal people will be here. So you have a normal distribution in those situations. Okay? So one, it will be bell-shaped and symmetrical. Okay? And the second thing, if you look at the situation that led to that random variable, you have instances that I've just described. Then you are dealing with a normal distribution. Now, there are important things to do with normal distribution, but first of all, I need you to do the following activity. Wait, why do I have so much? Oh, give to the next table. Quickly. Is this where I send you the soft copy again?
Yes.
All right, Mr. Soft Copy. Let's look at that for 5 minutes. The soft copy will have to be PDF, right?
Yep.
You're not welcome. Check.
Easy. Hey, why did you send the thing yesterday?
I'll focus on this. I don't really have time. Unless it's about this, then we can talk about it now. Otherwise, please talk to me about it later. And please state why. You don't have to say A is a normal distribution because B is a normal distribution because you can combine them. Oh, A, B, and C are normal distribution curves and state the reason together. You don't have to state it one by one. Okay? And Nakita, I don't think it's just one. Okay. Which of the following? When I say which of the following, in case that question sounds ambiguous, it's not just one. I wasn't referring to one, like as many as you can see. Are you done?
Number one.
Everything.
No.
Oh no, I just exposed myself in number 2. Number 2B. Is it possible not to hear what I said a moment ago? Just remove it from your memory. Oh, it says it's a normally distributed already, so just say why. And by why, just tell us why you think most of the data will be clustered around the average, the mean, and a few ones will be at the extreme, or maybe due to this and that.
Oh, you started and full stop, then this
Yeah.
is oh yeah, okay. That's what I was.
Okay, so I think the first one looks okay. Every table did the right thing. It is B, D, and F. And simply because they are symmetrical and they are bell-shaped. The rest are not. A, for example, looks what? It looks positive scale. Yeah. E is the opposite of that. C looks confused. Confused.com.
中青年人，就一个老人，一个老人是零青。找比较平的，很多人吧，因为他可能23、26、28、30、32，然后一个时区有50，可是很多都是在那个，可能就刚好2个26。
Okay, one more minute, then you can finish up later, so we can move on with our wonderful mathematical life.
The length of parallel is from the other side of the outside.
Mr. Chang, are you done? Okay, everyone, please stop. Because of our time, I'm sure you can always look through most of this stuff on weekends, so we don't want to spend so much time on exercise. Just for you to have an idea how to whatever. Now, the first one, we all agreed, they are B, D, and F for obvious reason. They are symmetrical and they are bell-shaped. It doesn't matter whether it is this bell shape or the tall one, it doesn't matter. We'll see what is responsible for being too stretched up, or what is responsible for the sliding, if I may use that word, the translation, in a minute. So for this one, can you tell me what you have written? This we've discussed. You will expect, because of time, you will expect that, why is it likely that the following variables are normally distributed? Oh, because we will expect that most of the students' scores will cluster around the average, right? Will be near the average, and only a few people, like very few people, will probably be at the extreme up or the extreme down. That would be the expectation, okay? Now, the average is not talking about a pass mark. It's possible everybody cluster around 90, okay? And you have someone who is probably in the 60, and someone who got a perfect score or even got extra, okay? And it's possible that everybody cluster around 40%. And you have someone who got a 0, and maybe 1 or 2 people who got maybe 99. We're saying most people will cluster around average. Some of these things are what is responsible behind the scene for your mark scheme, which is why mark scheme is never the same every year. A standard exam doesn't have a mark scheme that is the same every year. Oh, if you get 20 to 30, you're going to get a star. No. Check IGCSE, for example. It's always different. Okay? So they look at those marks, then they look at where everybody clustered, and that is where most of the time the pass mark will be. So if, as a school, I want to do a mark scheme as well, I want to do grade boundary, this is what we consider. Okay, so that we look at the deviation as well. So it might be that, oh, maybe C grade should be within either mu plus or minus, whatever, then start distributing the rest. Okay, something like that. Now, the next thing is the normal probability density function. Of course, the proof of the mean and the expectation is not required, but we might just play around it in the classroom. Although, according to this note, says it is bell-shaped, where you find it on the x-axis, on the horizontal axis, depends on the mean and the standard deviation. And where you find it depends on the mean, the spread depends on the standard deviation, sigma. Now, by the way, okay, this we already know. The mean is the measure of center. So which was why I said the mean tells you where the line of symmetry is. Okay? And the standard deviation tells you the spread of the distribution. So there's a difference between the spread of this and the spread of maybe this one. Can you see they spread differently? They have the same mean, but they spread differently. Being the probability density function, the total area under this curve must be 1. So imagine that total area under this curve for this guy is 1, and you must have another one whose total area under the curve is 1, but taller than this. Definitely the spread will be different. Because remember, everything has to be 1. Okay? Compared to the one that is like this. The spread will be different because everything still has to be 1. What is responsible for that spread is the standard deviation. You will see in a bit. Now, this is the notation you might want to watch out for in your exam. When you see n with this symbol, this, followed by the mean, then you will often at times see the variance, sigma squared. This simply means the random variable is normally distributed. It means the distribution of the random variable is a normal distribution. We call this mu and sigma the parameters. Just like for the binomial distribution. What are the parameters for binomial distribution? Say that again?
Number of trials and probabilities.
N and P. Those are the parameters. So for this, the parameters are mu and sigma. So a standard question will begin with, oh, the random variable has mean this and standard deviation that. Even if you are given variance, you get a standard deviation. Remember that variance, the unit of variance is going to be in square form. The whole idea of standard deviation is to bring it back to the normal unit. You are dealing with age. But when you calculate your variance, if you are to be truthful, the unit of variance should be age squared. But there's nothing like year squared. Rather, you want to talk about the variance, the spread of the age. And the spread of the age should also be in terms of years as well. Okay? And that is the whole point of standard deviation. Finding the square root of that is to convert it back like we did in the statistics that we did earlier, statistical measures. Am I making sense? So, although you will see it in this form, but we often just talk about the mean and standard deviation. Because those are the parameters we're interested in. But this is the notation you might be seeing. Now, so this is how you read it. You can either say x is normally distributed with mean that and variance that, or x is normally distributed with mean mu and standard deviation sigma. Okay? So, of course, this will be sigma squared. but of course you can say sigma. I think one of them was given in your book, but both are accurate. For a normal distribution, this is the density function. It's kind of look like the most complex so far, but it's not. And most of the calculation you are not expected to do manually. Calculator will help you out. And of course the normal curve. When we get into the normal probabilities, you will see how to use the curve to find your probability. So you don't need to memorize. But if you want to check yourself, you can check by finding the integral of this function within the limit range given. The definite integral. You put that in your calculator to check. But we are not going to bother you with that at this level. So if x is normally distributed with mean mu and standard deviation sigma, then the density function of x is given as that. Yes, sir.
So sigma, right? When it's squared, it means it is variance.
Yes.
Well, I think get variance when they use standard deviation in the formula.
What do you mean?
Like, why don't they just give a standard deviation in the notation instead?
It's a notation. I can't answer that question. That's a general notation. You see this in exam. X is normally distributed with this. You don't see it being written as that. It's always written in form of the variance. That's a good question I should have asked. I can't tell you why. But that's a notation. Just like me saying y is 1 times 2 is equal to 2. They have done all the work in the previous years, and we are just building on what has been done. It's a notation, nothing more. Okay? Alright. So, again, I said the graph of this function is called the normal distribution curve, or just normal curve. You don't have to say normal distribution curve, let's say the normal curve. So if I'm asking you a question, oh, what is the mean of this normal curve? It's the same as saying what is the mean of this normal distribution curve. Okay? So now we're going to explore some things before I get into these conclusions. I have the conclusions here. I have not given you for obvious reasons. There's a demo here we can use to explore the following. Yeah, I know. Let's read it. The question says, in this investigation, we will look at some interesting properties of normal distribution curve with the help of graphing software which has been provided and calculus. So we have to do that ourselves. Click on the icon, blah, blah, blah. Now, what effect do variation in mu and sigma have on the curve? When we vary sigma and when we vary mu, let's see the effect on the curve. Let's take them one by one. Calista, if you're feeling sleepy, you know what to do. Let's start with the mean being 1. Okay, let's light the mean, even with the way it was provided. Can you see? What effect does that have? Anyone?
It changes the location of the normal distribution.
Speak like a Form 6 student. Not it changes the location. Speak louder, miss. I can't hear you.
The translation.
It is responsible for the translation. Okay? Of course you are right, but use a big boy vocabulary. Okay? Oh, the mu translates the normal curve. Okay? And you can see that. What else do you notice? What else do you notice?
Mu is the maximum of the curve.
Mu is the
Maximum point.
mu is not the maximum point. Put it in a better way. You are right, but put it in a better way.
The x coordinate of the maximum point.
At the maximum point, x is mu. Okay? At the maximum point, x is mu. You agree with that? What does that tell you about the measure of the one of the measures of the center of the one of the measures of center? Say that again. Mu is the mode. Right? Remember, the mode is that value of x in the distribution where the probability is maximum. If this is a probability density function, we are saying here is this, here is this, here is this. Even though it's continuous, we're not talking about specific. Okay? But assuming we are talking about specific, just hypothetically speaking now. Say, oh, this one is corresponding to this value. This is corresponding to this value, something like that. Am I making sense? So our meal is responsible for the mode. Our meal is the mode. Okay? Now your meal is the mean. We all know that, right? So you can see that. What does that tell you about the mean and the mode then? Speak louder, Kerry. They are the same. Always speak with confidence. They are the same. Okay? Now, who can remind me what median of a distribution will be?
The 50th percentile.
Yeah, but in this case now, is it easy to trace the median?
Yeah.
Crystal, how? Speak like the birthday girl. What? What did she say? Mean. Did you say it's the mean? No. Forget about mean or mode or whatever. From this curve, is it easy to trace the median? I think she only lacks confidence. She's probably telling me the right thing. Anyone want to amplify whatever she has said? Yes? No one? Huh?
Median is mu.
Mean what? Don't relate it to mean or whatever. Just how can I get the median from this curve? That's my question.
You take the first value and the last value, add it together, divide by 2.
Why divide by 2?
Because we're trying to.
What do you mean first value, last value? How would you normally find the median? That's the way I need it to explain. Then relate it to what you see, not the way you present these answers. I don't like it. Yes, try.
The center of the graph.
Say that again?
The center of the graph. Like
Okay, why the center of the graph?
Because it's symmetrical.
Because it's symmetrical. Come on, this is from 6. Let's stop talking like we're in P6 and you need the teacher to give you one vocabulary to be able to speak. You're going to be on this odd seat yourself in the next 1 or 2 months. In 2 months, not 1 month. Okay? So let's use these vocabularies. Okay? Normally, your median is that value of x where the area, cumulative area so far, is 0.5. In this case, because it is symmetrical, it is definitely the center. It's symmetrical and bell-shaped. So we are not worried, unlike the line that we had yesterday. Remember this function, like this. You cannot say your median is halfway of this distribution, because clearly the area here is less than the area B here. So this wouldn't have been the median. And we saw that yesterday. We had a 1 and a 2, but we found our median to be at square root of 2 instead of 1.5. Something like that, right? So I don't know if this was the exact shape or the other one, but I think we found something like this yesterday. But this is different. We also mentioned that if you have a uniform distribution, it's easier, because all we have to do is consider the center. Okay? Now, why is uniform distribution kind of similar to this? Because of the symmetry. Understand? So the median is that value of x where you are rest assured that your cumulative area so far is 0.5. That can only happen if you are the center. Which means for this current picture, the median is what? 3. The mean is what? The mode is what? That is one thing that makes normal distribution stand out. The mean, median, and mode coincide. They're the same. Understand? The mean, median, and mode coincide. Now, we have seen the effect of variation of mean. Let's see the variation of standard deviation. Are you ready? Can you see that? What does anyone want to say about that? That's like dancing, birthday girl, dancing. It's Krista's birthday, it's Krista's birthday. Alright, anyone?
It stretches the curve
Yeah.
vertically.
Vertically.
Changes the maximum point.
Yes, changes the maximum, but what do you mean it stretches the curve? When what happens, something like that. That's what I expect you to tell me. As this is how you describe behavior. Oh, as x tends to